Hello everyone, and welcome to our second lesson on fractions, decimals and percentages. Today we're going to be learning about how to multiply fractions and fractions of amounts. So we've got quite a lot of goals to get through today, but you can pause the video at any time or rewind if you need to. In this section of work, we're hoping to know and understand how to multiply and divide fractions and decimals, to think about what happens when we multiply or divide a number that's less than 1, multiply and divide decimals by powers of 10, divide fractions and mixed numbers and multiply, how to express one thing as a fraction of another, and how to find percentages of amounts. We might not get to all those things, but we'll see how far we can go. So first question is, how else can we write 4/5? Well, we could draw a picture, but we could actually also write this as 4/5 times 1. We could write it as 2 times 2 over 5. What are some other ways you could think of? All right, so I want you to have a look now at this picture. And I want you to pause the video, have a look at it, talk with the person next to you, and write down, what do you see, what do you think, and what does it make you wonder? So just pause the video. I'm going to give you some time, and then we'll come back. Hopefully you're able to talk about some interesting things. But the cool thing is, we don't need to make pictures every time we multiply or divide fractions. We can look for patterns, and we can actually form rules that save us a lot of time. So if we look at this question here, for instance, we've got a half times a half. Well, what we're really doing is 1 times 1, so numerators multiplied together, and 2 times 2, denominators multiplied together. Similarly, if I go to the third example, 2 times 3 on the top gives 6, and 3 times 4 on the bottom gives 12. Always keeping in mind that we're going to simplify that fraction at the end. So just to remind yourself, make sure you are multiplying denominators together, multiply numerators together, and then simplify. Those are the 3 steps that you always want to do. And you can use improper or proper fractions to do this. In this first question that we're going to try together, it says to use the diagrams to make each calculation. Well, in the first question, we're doing a half of a quarter. So basically what I want to do is I want to take a half of that quarter. So that means I want to halve these. And if I take a half of this quarter, I'm literally going to only get one piece, right? I'm going to get 1/8. So doing it from the picture visually can be helpful, but I could also do that as a half times a quarter. And if I go across, 1 times 1 is 1, and 2 times 4 is 8. And that's the same with the other two. Okay, so with the next one, if I'm doing half of 3/4, then basically I can see that I'm actually going to get 3/8. In this one, I'm going to get 6/15 if I take 2/3 of 3/5. Okay. In number 2, they want you to make your own pictures. So see if you can have a go at doing that. If not, it's okay. You're more likely going to get questions asked to just work them out. Okay. All right, let's have a look at more questions. It says, by reducing the factors in the numerator and denominator, find. So this question is asking you to simplify the factors first. So what we're going to do is we're going to look for what's common or what we can divide by, the highest common factor we can divide by. In A, it's easy. I can do 4 divided by 4, which is going to leave me with 1/5. Because remember, that line there means divide. So in this one, I've really got 2 times 1 over 3 times 6. And 2 divided by 6 is a half. Sorry, is a third, is what I meant to say. And that's 1 over 9. Okay. In C, well, 4 divided by 2 is 2 on the top, and I've got a 1 on the bottom. So on the top, I'm left with 2 times 1. On the bottom, I'm left with 5 times 1. So my answer is 2/5. Okay, can you see what it means in terms of simplifying? In question D, it doesn't look like there is anything that can actually simplify. So in this question, I just need to write it out. 6 times 1 over 7 times 8. And that's 6 over 56. And then I want you to see if that can be simplified. Could we halve that and halve that? Or what's the highest common factor? I'm pretty sure it can be simplified. You see what it becomes out to. On E, I'm thinking about the top and the bottom of my fractions. Okay, here I can see 15 divided by 5 is 3. So that gives me a 3 on the top. And on the bottom, 4 goes into itself once, but into 16 4 times. So I've got 3/4 as my final answer. So in this question, they're asking you to simplify first. So in this one, for example, I can cancel the zeros. That's one option. And I could just go 4 times 2 over 5 times 3, which is 8/15. Or I could have done 20 divided by 5 is 4. And got the answer that way. So there's lots of different ways that you could actually get the same answer. In number 4, we've got some mixed fractions. So I highly recommend that you change to improper first. Okay, maybe make a note about that in your summary. We want to change to improper. We're not going to do all these, but we'll do some. So let's have a look at the second one first. So in B, I'm going to change 1 2/3 to 1 times 3 plus 2, which is 5/3. And 1 1/2 is 1 times 2 plus 1 over 2. Okay, and I can see straight away these 3's will cancel, so my answer is 5 over 2. Let's say we did D. So in this one, I'm looking at... Sorry, something's gone funny with my pen. There we go. So in D, I'm looking at 2 1/3, so I'm going to change that to improper. So that's going to give me 7/3 times 1/5. And that's going to be 7 times 1, 3 times 5, 7/15. Okay, you do the ones that we haven't done. We then come to a word problem. Now this is where things get a little bit more tricky, so we want to think carefully about how these work. Let's have a look. We want to get our highlighter out. Tristan eats 2/3 of a block of chocolate on Monday, and he eats half the remaining on Tuesday. First question, what fraction of the block remains after Tuesday? And if the block had 36 squares, how many had he eaten? So let's have a think about this. He ate 2/3 of the block of chocolate on Monday and 1/3 of the remaining block. Okay, so what this means is on Monday he ate 2/3 of the block. And then it says on Tuesday he ate half of the remaining block left over. So if he had 2/3 on Monday, that means there was 1/3 left to make 3/3. And it says that he ate a half of that 1/3. So a half of 1/3 is 1 times 1 and 2 times 3, which is 6. So that means there's 1/6 of the block left. Okay, so that's part A, what fraction of the block was left. Now for part B, it says here, if the block had 36 squares of chocolate, how many had he actually eaten? Okay, now I'm just going to go off what's left. So if there were 36 in total, and I divide that by 6, because I have 1/6 left, then that means he had 6 squares left. But the question doesn't ask me about how many squares left. It says how many has he eaten? So therefore, he must have eaten 30 squares, right? If there's 6 left. So I did that question that way. All right, continuing on, the next bit is to look at fractions of amounts. Just remember the word of in maths means times. So if I'm doing 1/4 of 28, I'm really doing 1/4 times 28 over 1. And that's just 28 divided by 4, which is 7. Okay, similarly, 2/3 of 30 is 2/3 times 30 over 1. And either you could do that as 60 divided by 3, which is 20, or you could do 30 divided by 3 is 10, and 2 times 10 is 20. It's up to you. Okay, then we apply it. So what if I have 1/10 of a kilometer in meters? Well, first I have to change a kilometer to meters. So 1/10 times 1,000 over 1. That's going to be 1,000 over 10. Cancelling out one of the zeros, that gives me 100 meters. Okay, 3/5 of a minute. Well, I've got to change that to seconds first. So 3/5 times 60 over 1. Well, 60 divided by 5 is 12, so that gives me 36 seconds. And then we've got some more kind of word problems here that we're looking at. And then we also want to get on to dividing. So I'm going to let you try 3 and 4, discuss them with the people next to you quietly, and then I'll make sure the solutions are posted later. With division, we're thinking on the same sort of lines as multiplying, but we've actually got to use something called the reciprocal principle. The reciprocal means inverting something or flipping it. Okay, so reciprocal just means flip. So for example, if I have 3/5 and I want to find the reciprocal of this, that would equal 5/3. Okay. And the rule for dividing fractions is you change to improper, you find the reciprocal of the second fraction only, and you multiply. So we actually get around dividing fractions by multiplying them. So let's have a quick look at some of these. The reciprocal of 3/4, that just means flip it, is 4/3. Now for mixed, you've got to change to improper. So this is going to become 11 over 5, and its reciprocal, which I'm going to call R, would be 5/11. What about if it's just a whole number? Well, 5 is the same as the fraction 5 over 1. So the reciprocal of that is just going to be 1 over 5. Okay, so if I want to divide two fractions, here's what I do. 3/4, I change the division to a times, and I swap the 8 and the 5. And then I just go across 24 over 20. Simplify that down. Highest common factor of 4 here. So 24 divided by 4 is 6, and 20 divided by 4 is 5. Okay, so remember just doing top times top, bottom by bottom. Another way to remember this is tumble and times. So on B, I'm going to make it improper, so I'm going to get 4/3. I'm going to times, and I'm going to flip the second fraction to 1/6. 4 times 1 is 4. 3 times 6 is 18. That can be simplified to 2/9 if I halve them. Okay, C, you would change both of them to improper. So see if you can do that. Question 3 is a bit more of a tricky word problem. I'll start you off, but I won't have time to go through it all. And